Hello students, last class we discussed about half wave rectifier and here I would like to mention one more point. So your half wave rectifier, your diode conducts during only positive half cycle. The negative half cycle your diode will become reverse biased, so it will act as an off switch. So the entire voltage will be applied across the diode. When the next cycle comes during the positive half cycle, your diode will conduct, so the entire voltage, the input voltage will be applied across the load. So across the load we are measuring the output voltage. So your diode will become on during positive half cycle, it will become off during negative half cycle. This is repeated for the further cycle. So this negative half cycle will become a drop across the diode. That's why it is represented as VD. And half wave rectifier with the filter. The purpose of rectifier, it should convert AC voltage to DC voltage. The DC voltage must be a constant DC voltage, not pulsating DC voltage. So how can we get the constant DC voltage from the pulsating DC voltage? The one way is that you can use a filter. It means you can connect a capacitor across the load. So this is the waveform without filter. If I use a capacitor, my DC voltage will become like this. So this is known as ripple or ripple DC. If I tune the capacitor, I will get the pure DC value. I will get the pure DC from the rectifier. So that is the purpose of filter. So next we will discuss about full wave rectifier with that is center tap transformer based full wave rectifier. So what is center tap transformer? So this is an ordinary transformer. It has primary winding and secondary winding. Primary has N1 turns and secondary has N1 turns. Suppose if I split the secondary with equal number of turns, that is N2 by 2 turns, here N2 by 2 turns, then I am getting 3 terminals in the secondary side. So this transformer is known as center tapped transformer because the tapping is taken from the center of the secondary winding. Suppose if I apply 100 volt in the primary side in ordinary transformer, suppose if it is 1:1 transformer, the secondary also I am getting same 100 volt. If it is a center tap transformer, the secondary is equally divided. So if I apply 100 volt, the first phase I am getting only 50 volt, then the bottom side I am getting, bottom part I am getting 50 volt. So this 100 volt is divided here 50 and 50. So the turns ratio is I am applying 100 volt, so take it as 1. The secondary side I am getting, this is N2 and N3, so it is 0.5 and 0.5. So this is 50 volt and 50 volt. So what is the behavior of center tap transformer with AC supply? So if I apply a AC supply to the center tap transformer, suppose if I am applying positive during the positive half cycle, in the top portion I am getting the same positive half cycle, but the magnitude is half of the input voltage. In the bottom portion I am getting this kind of waveform. It is 180° out of phase. So this is the response or the output waveform for the positive half cycle input. If I apply a negative half cycle, then the output will become like this. It follows the top portion follows the input waveform, but the bottom portion is 180° out of 180° phase shifted with respect to the input. So this is the top portion and bottom portion output. Here I am applying a magnitude Vm, but on the output side I am getting only Vm by 2. In negative I am getting only minus Vm by 2. So this you have to remember. So behavior of center transformer with AC supply means same. So during positive half cycle I am getting such kind of waveform. In the second portion I am getting 180° phase shifted waveform. So this portion will plus minus and negative portion will act as this side will become plus and minus. During negative half cycle, minus, plus and minus, plus. So this plus and minus will cancel each other, so you will get 0 volt. So remaining thing we will see in the next class. Thank you.